Viewers, welcome to Emmanuel Mass Academy. So in the previous video, we were able to look at variation and the types of variation. We looked at direct variation, inverse variation. So today we'll be looking at joint variation. What is joint variation? Joint variation is a combination of both direct and indirect variation. You can have direct, direct to direct, direct to indirect, and you can also have two indirect, or you can call it two inverse variation. Right? Look at what I mean. If you have three variables, A, B, and C, I'll say that A varies directly as B and C. It is expressed like this, right? Then the equation now becomes A equal to K B C. You now introduce your K, where K is the constant of the variation, right? Let me just write the statement down. A varies directly as what? B and C. You can also have a statement which says A varies directly as B and inversely as C. It will be expressed as A varies directly as B and inversely as C. The inverse will not come under. Is that correct? Now the equation now becomes A equal to KB over C, right? Let me just write the statement. A varies, or you can say A is directly proportional. It's the same thing. A is directly proportional to B. A is, we can even say proportional, is proportional to B and varies inversely as C. This is the statement here. What about if you have that A varies inversely as B and C? That means both the B and C will not come as the inverse. Look at the expression here. Varies inversely as B and C, right? The equation now becomes A equal to K B C. I say that A varies inversely as B and C. As simple as that. Let's look at an example. Example 1. If Y varies jointly as X and Z, and Y equal to 45 when X equal to 18 and Z equal to 10, full stop, find Y when X equal to 20 and Z equal to 30. From the statement, you can see that this is an example of joint variation. Say that Y varies jointly as X and Z. This is an example of joint variation. You start solution. We have that Y varies directly as what? X and Z. Equation is what? Y equal to KXZ. From this, you say that our Y is 45. Y is 45. Our X is what? 18. And our Z is 10. Right? Now substitute the value of both Y, X, and Z in our equation. Now substituting this into this equation, we have what? 45 equal to K. X is what? 18. Our Z is 10. 45 equal to K. 18 times 10 will give you what? 180. Right? Now make here the solid of the formula. Dividing both sides with the coefficient of K. What's the coefficient of K here? 180. Divide this side with 180. Divide this side with 180. 180 divide 180. If this should divide this, you have 1 over 4 equal to K. That means our K is equal to 1 over 4. Right? Is that correct? Now, this is the first part. The next part says find y when X equal to 20 and Z equal to 30. This means that when X is equal to 20 and Z is equal to 30, right? Our Y is not known. Is that correct? Now from this our equation which says Y equal to K X Z. we have that y is equal to what? What's our k? Our k is 1 over 4 times, what's our x? Our x here is 20 times, our z here is what? 30. We now have that y is equal to 20 divided by 4 will give you what? 5. 5 times 5 times 30 will give you what? 150. 5 times 30 will give you 150. That means when x equal to 20, z equal to 30, our y is what? 150. As simple as that. As simple as that. Let's look at another example for better understanding. Now let's look at the second example. Example 2. It says if y varies directly as x and inversely as z. This is an example of what? Joint variation. Right? Now let's express this mathematically. Solution. So that y varies directly as y varies directly as what? X and inversely as z. Right? The equation is now what? Kx over z. Right? They say that our y is 4. Y is 4. Our x is what? 6. And our z is what? 3. Now substitute the value of both y, x, and z in this our equation. We have what? 4 equal to k times 6 over 3. Right? If 6 should divide 3, we have 2 here, we have 1. Then first multiply. These two will come down to this place, right? Now have 4 over 2 equal to k. That means our k is equal to 2, right? Now the second part says find y when x equal to 15 and z equal to 10. Is that correct? This simply means that when x equal to 15 and z is equal to 10, our y is not known, right? Now from this equation, we have that y is equal to kx over z. Now what's our k? That is equal to what? Our k is 2, right? Our s is what? Our s is 15. Is that correct? Then our what? Our z. Our z is 10, right? If they should divide this, we have 1 here, we have 5 here. Now have 15 over 5, which is equal to 15 over 5. 15 divided by 5 will give you 3. That means when s equal to 15 and z equal to 10, our y is equal to 3. As simple as that. As simple as that.